Welcome to solverfy.
So how long would it take for us to catch up if we reduced our radius of orbit by 1 kilometer? So for part A, we can say that the original velocity is equal to the gravitational constant times the mass of the Earth divided by the original distance. We can say that v is equal to the square root of gm sub e divided by r, the original distance, minus delta r, the distance that you were brought back, or rather the distance that the distance that you traveled in the direction of to the direction of the center of Earth. So we can say that r sub o is going to equal simply the radius of the Earth plus however far you are off the surface, so 4 times 10 to the 5th meters, and this is giving us 6.78 times 10 to the 6th meters. And then we can say that r, the original distance minus the change in distance, will be equal to 6.779 times 10 to the 6th meters. So we can create a relationship with the kinematics and say that the velocity times time will be equal to the velocity initial times time plus 2.5 times 10 to the 4th meters, because that's how much distance we're trying to make up. So we can say that g sub e divided by r original minus delta r to the 1/2 power is multiplied by t will equal gme divided by the original distance times t plus, again, 2.5 times 10 to the 4th meters. Apologize for it being cramped. And we're going to call this equation 1. So let's just call this equation 1. So when we solve for t, however, here, we can see that t is simply going to be equal to 2.5 times 10 to the 4th meters divided by the square root of the gravitational constant times the mass of the Earth times 1 divided by the square root of the original distance minus the change in distance minus 1 divided by the square root of the original distance to the negative 1st power. So this is simply due to algebraic manipulation, and we're trying to isolate t in this case. So t, we can then solve and say that t is going to be equal to 2.5 times 10 to the 4th meters, and then this will be the square root of 6.67 times 10 to the negative 11th times 5.97 times 10 to the 24th kilograms. And then this will be multiplied. I'll write it down here. This will be multiplied by 6.779 times 10 to the 6th meters, and then 1 minus 1 divided by the square root of 6.78 times 10 to the 6th meters. And we find that the t is going to be 4.42 times 10 to the 4th seconds, and that's in order to catch up. So approximately 10 to 12 hours you would need in order to catch up. This would be your answer for part A. And then for part B, my apologies. There we go. And then for part B, we have that from equation 1, again, here we need t to be equal to 7 hours. We need to catch up in exactly 7 hours. So from equation 1, we have that 1 divided by r naught minus the change in r equals 1 over the change, rather 1 over the square root of the original distance plus 2.5 times 10 to the 4th meters divided by the square root of, rather we can say divided by t times the square root of GME. So this is simply algebraic manipulation from, again, equation 1 here in order to isolate the original distance minus the change in distance. So here, then we can say that the change in distance is simply going to be the original distance minus 1 divided by the square root of the original distance plus 2.5 times 10 to the 4th meters divided by t times the square root of the gravitational constant times the mass of the Earth, all to the -2nd power. And solving, we can say that delta R will be equal to 6.78 times 10 to the 6th meters minus, and then we'll have 6.78 times 10 to the 6th meters, and then plus 2.5 times 10 to the 4th meters, and again, it's all to the -2nd. And then here it would be 25,200 seconds, so 7 hours, and then multiplied by the square root of 6.67 times 10 to the -11th times 5.97 times 10 to the 24th. And we find that delta R is going to be equal to 1,755 meters. So you would have to, instead of decreasing your distance from Earth by 1 kilometer, you would actually have to decrease it by 1.755 kilometers in order to catch up in only 7 hours, rather than this would be about, again, 11 hours, 12 hours. So in order to decrease your time, you need to increase your change in distance. And so this would be our final answer for part B. That is the end of the solution. Thank you for watching.